All right, so welcome everyone. So it's 12 o'clock, so we're at the next session here at the Kronos BOF at SIGGRAPH 2023, and we're going to do a deep dive into the newly announced Anari rendering engine API, and we're very honored to have Bill Sherman here from NIST. So over to you, Bill.
All right, thank you, Neil. As Neil said, I'm from NIST, which is the U.S. National Institute of Standards and Technology, and I'm here on behalf of the Anari working group. I'm more of on the application side of Anari, whereas many of the members of the group are part of it's kind of the back-end development, and I'll talk a little bit more about that later. So this slide gives some examples of different ways, different rendering techniques you can apply to the same data set. So as you can tell, this is the same data set, but sometimes we have ambient occlusion, sometimes we have directional lighting with shadows, sometimes we have self-shadowing. And so depending on what your goal is, you may want some or different techniques to be applied to your data set, especially in scientific visualization, but also in VFX and things like that. So let me talk a little bit about the goals of Anari. So we are not officially launched as a 1.0 version. We expect that to happen in the near future, but we're anticipating that things are kind of solid for 1.0 right now, and that it'll be approved in Q3 of this year. So, but the goal really of Anari is to be the simplified application development layer, so that if you want to make a new application and you want to take advantage of advanced rendering techniques, ray tracing, path tracing, what have you, you don't have to learn or take someone else's library and write a specific interface to their library. You can write one interface and connect to a lot of different back-end renderers. So we want this application portability. That's kind of what this is all about, right? So on that first slide, we talked about visualization examples, and a lot of the examples you'll see today are from the visualization realm, but that was really just kind of where we started, and in the recent past, we've been moving on to other areas of rendering. So this is kind of the classic standards need, and you'll see a lot of Kronos APIs use the same thing, where we had at the beginning several different applications, which all, if they wanted to use a different renderer, had to write their own interface to that renderer's API. And so with Anari, we stick in a simplified API level in between, and now your application can select at runtime which rendering style or which rendering code you want to access. And so that's really the big win that we're going for here. So another way of looking at that in a more detailed level is that Anari sits just below the application layer and above all the kind of complex things that happen if we go all the way down to the bottom. We have hardware, the CPU or GPUs, and then with modern GPUs, which 5 years or so ago introduced ray tracing capabilities right at the GPU level. And so a lot of acceleration APIs depend on that, or do some rasterization, making use of the GPUs. Several of them are listed here. But then on top of that layer, a lot of especially ray tracing applications have taken advantage of these new GPUs. So Intel has their Osprey, AMD has the Radeon Pro Render, and NVIDIA has VizRTX, and VizRTX 2 now. And so if you want to take advantage of any of those, Anari lets you link to them, and implementations of all those already exist. There we go. All right, so some more kind of diving down a little bit into the details. The specification is written for C99. That way it kind of has this broad application. Doesn't preclude us from moving on to kind of more new languages like C++, right? So there's a C++ implementation that already exists. It has wrappers, makes sure everything is type safe and what have you. Within the last year, we've added a Python binding, which is really still kind of at the prototype level, but it basically takes all the features of Python, especially the NumPy side of things. If you're doing more scientific work, have lots of data, you can use Python and Anari to link to these other backends. And then there's several example applications. If you download the basic Anari SDK, you'll get a tool called Anari Viewer, which just lets you try out different test suites on different rendering applications. And then recently we've added a conformance test suite to test all the backends and make sure that they match the Anari API. And that's also based on Python. So there's several backend layers that exist. When you download the SDK, I'll talk a little bit more about this later, but there's one called HELIDE, which comes built in, and it's really just a test renderer so that you have something to go with once you download the SDK. But there are also other, from the specific vendors, you can download their specific backends to Anari. And so those are on separate repositories controlled by each vendor or whoever writes the backend. But along with the standard SDK, and I should actually, let me point out at this point that Anari itself is really just the specification, right? It's just a document that this is how the API is specified. But to get the community growing faster, we've already implemented the basic SDK for C, C++, Python, also several backends that are already going. So the SDK is not really officially what Anari is, but we provide that to get everybody joining the community and going more quickly. So one of the things that comes with this SDK that we've implemented are two extra backends. One's called the debug, one's called the trace. So the debug does things like, say, make sure that you've provided this right type when you specified an array of values, right? And so it'll print that out, and then it will pass through. There's a diagram that's coming later where you see that it'll pass through to the other libraries. And the trace one does kind of more advanced, more additional tracing of the debug. The HELIDE I mentioned already, that's a sample implementation of the back end. So in addition to doing some rendering, the code is there. So if you want to write your own back end, you have this example code to work from. It's not the most advanced rendering system. It's there to be, kind of a clean code example for you to look at and build your own from there. So you can learn how to adopt your own to the SDK. And then I'll talk a little bit more about this later, but one of the things that we're adding to the SDK now is a third-party user who joined Anari, not as a member of the working group, but kind of as part of the community, and he implemented a remote rendering system that we can now provide with the Anari SDK. We'll talk more about that later. So one of the side benefits of Anari than having these backend libraries is that they can be connected in at runtime, right? They're just plugins. They're shared object libraries, DLLs on Windows, that can be connected at runtime. So you compile your C or C++ application, you link that with Anari all at compile time and loading time, linking time, and then when you run it, you can specify which of these backends you want it to run with. And so I think probably it's a little more flexible even if you're using the Python, because then the application doesn't even have a compile time, right? So here it is with that debug layer added in. So the debug later also gets added at runtime, and you can see it's a pass-through, right? So it's going to add some output to your console or to a window or what have you, and you can use that, as I said earlier, to make sure that your calls to the API are in the right order. You didn't try to create a scene, but you hadn't created the device yet, things like that. You have to make sure some of that stuff happens in the right order. So the debug layer checks that for you. Some of the backends will handle errors, right? And so this can be a problem if you're always testing with one backend and everything's working fine, but then you go to run on another backend and something's broken, because some of them are more forgiving than others. And I've discovered this a few times where I've written things like, oh, it's working great, try it with somebody else to see how that improves the rendering, and then you get a blank screen. So it's like, well, something went wrong. But no, the bug was in my code. I just didn't know it because I was using a forgiving backend. So I hesitate to call this a scene graph, but it's kind of this node-based, right, system of how the data is stored in memory. At the top, we have a frame, and the frame then has the world, which is where the geometry is going to reside, along with the lights. And then you have a renderer, which is a particular part of the back end. So actually, a back end can have more than one rendering style. You can do path tracing or ray tracing, and those can all be part of the same back end, and you can select those then at runtime which one you want to do. So you select the renderer. All renderers or all backends are required to have a renderer called default. So if you want, you can just select the default and you'll get that. And then you have the camera, of course, so you can choose which direction to render to. The world then has objects below it, including lights. We can render surfaces or volumes, and I may have a slide that talks about it later, but I'll mention now that backends to be conformant, do not actually have to do everything. So, for example, we can have different kinds of surfaces. We can have triangle mesh surfaces. We can have parametric spheres or cylinders. And a back end can say, well, I'm just going to do spheres, or I'm just going to do meshes, right? And there's a query system where your application can query the back end and say, are you going to provide me with the ability to render spheres, or should I convert all my meshes into spheres, right? Or just ignore spheres, however the application wants to handle it. So the API says, there's the opportunity for triangles, there's the opportunity for spheres, but the back end actually gets to make the call as to whether whoever implemented it wants to go that far. Now, of course, if you don't implement very much, no one's going to use your back end unless it's something specific you're trying to accomplish. You can create objects and instance them, so that's kind of standard scene graph. But there are other aspects of scene graphs like switches or animated nodes that we don't handle. That what you would have to kind of do on your own. You can do some of that through the instancing node. So here's some of the applications. I mentioned earlier that we started with scientific visualization, so that's where we are here. VTK is kind of the low-level visualization rendering system, and that is written so that it's in the Kitware GitHub repo now. It is not part of what you would download right away. You would have to get a certain branch, but in a near future release of VTK, it'll be in the master pre-compiled branch. So VTK is used by both Visit and ParaView. So if you want to use Visit and have Anari in it, you have to get a special version of the VTK. But this is all just temporary, right, as we're releasing things now. But Visit has an implementation then based on VTK. ParaView also based on VTK. We're not quite releasing that yet. The interface isn't quite finished for that. So at kind of release time now, Visit works, VTK works, and also VMD works, the visualization of molecular dynamics tool from the University of Illinois. And so that one works, and that's one of the ones actually that wanted spheres and cylinders because, as you're familiar with, a lot of times molecules are modeled that way, although this representation is more of a ray tracing of potential fields rather than that. But if you want to go back to ball and stick models, those are right there in the API. All right. So as I mentioned, though, scientific visualization was really just where we began. We've now been expanding into the modeling and FX areas. So we have a proof of concept version working in Blender right now that takes advantage of both our Python language binding for Anari, but also the fact that Blender uses Python in its add-on system. And so that the two combined lets us work with Anari right now in Blender. So that will actually work. There's another backend that I haven't mentioned that actually the backend renders to USD, right? And so once you have it in USD, you can then bring it to other things like Omniverse and manipulate things right there. So there's this link to the FX world and the metaverse world through that as well. Here's another example of where we've rendered a scene, the San Miguel scene using VizRTX. And so just a non-science one, but you can see you get a lot of the self-shadowing, the soft shadows from the harsh sunlight, but distant sunlight. So kind of a nice scene that we can render as well as the scientific visualization. So I want to talk a little bit about the timeline of Anari. We have kind of two tracks I'm going to talk about. So an exploratory committee for Anari was formed back in 2020. Based on the fact that a year or two earlier, a lot of advances had happened in the GPU hardware realm, and so there were a lot of new APIs coming out to take advantage of doing rendering or ray trace rendering on the GPU. And so the exploratory committee formed and worked on a specification, right? So that's, like I said before, that's our real product of Anari, is the specification itself. And so we had a provisional specification that came out almost 2 years ago. At the same time, in order to make sure that we're on the right path, we've been implementing the specification ourselves, and so we've had several iterations of that. Right now, we're calling the implementation version 0.7. As soon as the final specification comes out, we're going to renumber that to 1.0. There will be if there's any changes, they will be minor between the two. So if you download it now, you'll probably get 0.7.0, but you'll really be working with the equivalent of the 1.0 branch. And so the specification we're expecting to go to the Kronos board in the very near future, and we expect it to pass in Q3, depending on what feedback there was. Between the provisional and today, though, we released it to the public, so we got feedback from several groups. That's why we added some features like the spheres and the cylinders. Other things have happened. Some of the third-party stuff I'm going to talk about later happened because we released it. We did a little webinar, and so we had people interested in that. So, as I said, you can get it today. There's an Anari SDK, which is, again, not the official product, but exists and has all the samples, has the library, has the HELIDE open source example rendering library. And then, as I mentioned, you have to go to other people's GitHub repositories or wherever they have it to get the Radeon, the AMD Radeon Pro Render, or the Intel Osprey, or the NVIDIA RTX, Viz RTX, or the Omniverse implementation, the USD Omniverse implementation. And so these will all be conformant, officially conformant, once the spec is approved. All right, so one of a third-party examples, so Stefan Zellman from the University of Cologne came to our webinar from a year or so ago and was excited about Anari. So he had already written his own specialized render that did adaptive mesh refinement. He was writing that and wanted to be able to compare it, right? So he's doing academic research. He wants to compare both the rendering quality and the time to render. And in order to compare that with, say, Osprey or Viz RTX, he decided that once he discovered Anari, he could write an Anari implementation, API implementation of his renderer. So he basically wrote his own back end. And now, at runtime, he can just switch which back end he uses. He can do timing analysis. He can kind of look at visual quality, however he analyzes that. And then he also, now that the VTK product was out, he could also compare using VTK of the same data. So this is really one example of where the big win comes from using Anari, right? So you don't have to write your renderer and then go and figure out how to get your same data into somebody else's renderer once you're using the Anari API. So there's a paper about that was published earlier this year. I mentioned at the beginning the ability to do distributed rendering. So Stefan is the same person who, when he was working on his back end, he wanted to be able to render on one big machine, but display it where he was working, at his office somewhere else. And so he went and made a new back end that sent the Anari commands to kind of a receiver, front end, I guess you'd call it maybe, receiving end, do the rendering there, and then send images back as compressed using JPEG Turbo or Snappy, so to get good feedback. And so that's going to come. We're actually going to include that in the Anari SDK that gets released. So that'll be one thing that the community has already contributed. And another user example is myself. So I mentioned at the beginning, I'm more on the user side of things rather than the rendering research side of things. And my area of work is doing virtual reality and specifically scientific visualization in virtual reality. So I've implemented both a cave style and a head-mounted display style implementation based on Anari. One of the kind of, holy grails of virtual reality has been to take ray tracing, make it real time, and put it into VR. And so in the past, there have been efforts to do that, some more successful than others, but now we've made it fairly easy to do. So for the cave, I use my free VR library. And we see that running in the upper right picture. There are some issues still, so you'll notice the rendering is all happening on the front screen there. We're still working on making things work better on multiple screens. And then the lower right one is on the Elixir library, which is an open source, open hardware platform that from the University of Illinois, a group that I've been working with. In the very near future, we'll do OpenXR. We just had the OpenXR session, so probably before the end of the year, we'll have an OpenXR implementation as well. But we're still working on things like the API specifies that you can have a regular camera, you can have a stereo camera, you can even have a 360 or cube map camera. But as I mentioned at the beginning, backends don't have to implement everything that's in the specification. You query to see if they do. So I don't know, I'm pretty sure none of our backends yet handle cube map cameras. I don't know whether any of them do stereo yet, so I don't think any of them do. So we still have to work on that. Right now I'd have to render the scene by changing the camera position and to get my stereo effect. But with a stereo camera, I can query the back end, say, hey, do you just provide a stereo camera? If you do, I'll do that. Oops. If you don't, I'll just have to render twice, right, and cut my frame rate. And so we also need to do the multi-threading, which I mentioned for the cave. So that's where we kind of the near future, things we're working on. In the slightly more distant future, things that are coming next is to integrate with more libraries, especially Kronos libraries like OpenCL. And so one of the things that if we're using OpenCL in an application now, the application has to kind of go out, do your OpenCL work, bring that data back, and then ship it back to Anari. We'd like to make that so we don't have to be shipping the data quite so much. So we want to integrate other libraries more seamlessly into Anari. Another area we're working on is to be able to do cluster rendering, right? So that we can send part of the scene to different CPUs or GPUs and have part of the scene rendered and then bring it all together at the end. And also distributed rendering. So we already actually have taken a step in that direction thanks to Stefan's work. So that's one of the things coming up. And then finally, we're looking at expanding how our materials work. So right now, we've taken the lead from GLTF and its physically based rendering, and we've integrated that as part of the standard. And I'll reiterate, not all backends necessarily handle that, right? You have to query to see if that comes in. But we know that people are doing other things with shaders and shader node graphs where they're going to want more flexibility in their material shading, material rendering. And so for that, we're actually looking for input from the community as to what's the kind of going method of doing that. What's the best method of doing that? And so we welcome new members to join our working group and give your input. You know, try things out, give input, show us how things work or don't work. I should mention that our working group right now is about 10 to 12 people arriving, attending meetings on a regular basis. We meet Wednesdays at 2 o'clock Eastern time, so 11 o'clock Pacific time. Is that right? No, it's 1 o'clock Eastern time, 10 o'clock Pacific time. And we have people from Europe as well. We don't have anybody from Asia attending on a regular basis, but we do have people from Europe attending, so a little later for them. And of the people attending those meetings, most of them work for the GPU manufacturers. I'm one of the few that show up that come from the application side, so if there's more people who are on the application side, we'd really welcome your input and encourage you to join. So I mentioned already that, you know, cameras, we already have a couple camera modes in the API. We'd like to see them in the back ends, of course. And we'd like to get a lot more for kind of visual FX people to participate so we can really make sure that we're heading down the right path when we add materials, properties, and things like that. We're going to, you know, further things we can do is add more languages. Like I mentioned, we recently added Python. So Rust, other languages, and then our debug and trace layers that I mentioned, there's still some room for improvement in those, so those will be improving over the next few months. So I just kind of said this, get involved, right? That last URL will get you the SDK. You can clone it from GitHub, compile it, it uses CMake, so build it from that. The docs, though, is what is really the product that we have, right, the specification, so you can also get that. And then we have an Anari page off the main Kronos page. And so that concludes the talk. If there's any questions, I'd be happy to take those. Yeah.
Hi, Bill. What is Anari replacing?
Right, so it's, there are other examples of APIs that kind of do the same thing, but it's mostly, I don't know that there's an exact replacement for it, you know, at the moment. Let me scroll back here. You know, so there are, like I said, there are similar things. So you might think that maybe USD is something that's kind of like this, or Hydra is kind of like this. But really, Anari is trying to be more general than those are, and also kind of integrate to those as well. So I don't know that there's really a direct thing that we're replacing. I mean, if there were, maybe it wouldn't have been a good idea to create a new standard, right? So we feel that it's kind of a new thing that the community needs in order to make this connection between applications and hardware. Yeah.
So I had just assumed that all those various rendering engines had serious incompatibilities in terms of what they support, in terms of how they support it, in terms of the kind of data you have to provide, in terms of what happens. So I was curious, was that actually the case, and if so, how does Anari address that?
Right. So not all of them necessarily support some of the features like sphere rendering or cylinder rendering. That was kind of a request that came from the molecular visualization group. So I don't know whether, I know that VizRTX and VizGL do. I actually don't know whether the other backends handle that at the moment. And so the APIs, if they're more concerned with fast polygonal mesh rendering, they can ignore that for the moment. Certainly things like, I do know that like Osprey has maybe better materials handling at the moment. So if you want to more refinedly control the materials on your meshes, you would choose that back end. And as I mentioned, Anari has this querying method. So you can say, do you handle this kind of ambient radiance feature? If so, I'll send you that data. If not, then maybe I'll pop up a warning to my user saying the selected backend doesn't handle this certain thing, so it's going to affect the look.
So to feed that back, the cases where something simply can't support it, you can either like polygonize the sphere, or you can simply say, I'm sorry, if you want that feature, it's not available in the API that you want.
Right. So if you don't bother to query whether you can handle the app backend can handle spheres, you can just send the spheres, and the backend will just ignore them. Right. It's not the backend's responsibility to convert them to meshes. It's really that's on the application side of things. So that's why we have this query system, and it's then the application can decide, well, I won't bother with the spheres then, or I'll send cubes instead, since I don't want to have too many polygons in my rendering system if I'm trying to be more real time. Does that answer the question? Yeah.
Yeah, so thanks for the talk. So I was curious about, have you ever considered Anari to be used on the game development side and the game engines? Was it ever considered when coming up with the specs and the design?
Right. So that's one of our facts here. Let me see if I can scroll. So none of us in the group are game engine developers. Some of us use it. I've used game engines on VR stuff, of course. There's nothing really that precludes that. The typical issue with game engines is that they want to involve at more fine-grained level than kind of Anari is going to provide. Maybe they need more of the shader stuff that we haven't implemented yet. But certainly at a overarching level, there's no reason that game engines couldn't use Anari and then have different ways of rendering. Use different. If you're on, say, a machine that has an NVIDIA GPU, use the NVIDIA backend. But if you're on a machine that has an AMD GPU, use the GPU backend. It tends to be that game companies want to know exactly what it's going to look like, regardless, right? So they may not want to go in that direction, but there's nothing that would stop them, if they want to try that.
Could you amplify a little bit more, because you're coming from the end user perspective, why, as well as giving the portability, Anari is making the programming task simpler?
Right. Well, yeah, especially for me. So I've wanted to get real-time racing in my VR for decades, right? So now instead of having to learn Osprey and learn the intricacies of getting Osprey to work, or learn VizRTX and kind of the intricacies of that, the Anari API is really fairly simple, right? I can specify my polygons, give it a material, tell it where the lights are, put the camera in a certain place, which in VR I'm going to move around a lot, and so it's pretty simple. I had a slide that I'm not including today, but when I go to render, say, to VTK, I just take my normal VTK Python code or whatever, and I add 4 lines of code, and now I'm rendering real-time ray tracing at least, using VTK, and instead of the VTK normal rasterization rendering, you know, it's just this trivial little change. I just add a few lines of code and I'm there. And so really that simplification is what gets me, because I didn't want to have to learn, you know, all the intricacies of how ray tracing works and all that stuff. I actually, since joining the working group, I'm learning some of that stuff, but for other people who don't want to spend that time, want to jump in right away, you know, using this API lets you really, you know your mesh, right? You know, it's pretty easy to manipulate your triangles, manipulate your transform matrices, and so really knowing that, putting cameras, putting lights, and you're there, right?
Okay. This is a question from our live stream. Someone's planning to use Anari for an API between SIGGRAPH and a Vulkan render. How hard will it be to integrate OpenXR into this scenario? Is there any abstraction that requires multi-cameras or single stereo pass for one viewpoint?
Right. So let me talk about the last part first. So the cameras we have, the specification does talk about different camera models. So of course we have a simple model, we have a stereo model. Going back to what I said earlier, the backends may or may not implement the stereo model. We've also talked about having a 360 or a cube map model of camera, and again, that's up to the backends to implement that. I don't know that any backend presently implements that, so that's something you can query for and find out. With respect to going to Vulkan, we don't have any backends right now that go straight to Vulkan. I may have skipped over it, but I think it's on one of the slides where that's one of the things we want to do is kind of get to the metal maybe a little quicker, and so you can have a Vulkan rendering. And read me that first sentence again.
Planning to use Anari for an API between SIGGRAPH and my Vulkan.
Oh yeah, SIGGRAPH. Yeah. So depending on how complex your SIGGRAPH is, I mean, you saw the Anari kind of tree-based node system is pretty simple, but it does allow for instancing. There are some features that I kind of wish were there, and so this is kind of a conversation going on now. So, for example, having a SIGGRAPH where you can turn nodes on and off, right? Instances on and off. We don't presently have that feature, or to have maybe an animated node where you have several children of a node and you kind of go through them. So, you know, kind of a true computer graphics SIGGRAPH, which has a lot more complexity, doesn't, you know, translates to a degree to our current node system. But I think there are some ways, you'll have to kind of do some trickery at the moment to get there. Or join the working group and encourage us to implement those features.
And for someone who could write their own highly customizable or optimized renderer, do you see any benefit of using Anari as a domain expert, or is that not your target audience?
Right. So actually, that's perfectly fits with the use case that I mentioned with Stefan. So when Stefan was working, he was writing an adaptive mesh refinement renderer, right, that does volume rendering. And so he had written this before he had discovered Anari. And so he had it working. It was running fine, but he couldn't, for kind of research purposes, he couldn't compare the rendering quality or the rendering speed very easily without having to say, then go write an Osprey version of his renderer, you know, where he still uses adaptive mesh refinement, but now renders using Osprey versus his own volume renderer or VizRTX. And once he discovered Anari, he realized if he just puts his custom renderer as a backend to Anari, all he has to do is flip a switch and he can go back and forth. I think, did you have a question?
Has Anari been compiled with all the latest GLTF and PBR extensions?
For which?
The GLTF extensions, PBR extensions.
Oh, yeah. So, no, the GLTF integration is something that we're actually undergoing right now. We're starting with trying to get the physically based rendering part of GLTF implemented as a Anari thing so that you could write a translator, but we don't have a if you get the SDK right now, you're not going to get a GLTF.
Right. Okay.
Yep. Looks like we have another question coming.
Yep. Another question from the stream. So, isn't Vulkan already cross-platform besides Apple Metal?
Sure. But Vulkan isn't. So Anari sits like, several layers above Vulkan. Let me bring that slide up. So you don't have to get down to the metal. Like I said, when I'm writing my VR examples, I still do not know Vulkan coding, right? So I can free myself from having to go down that learning path. Maybe someday I want to learn it, but at this point, I don't have the time to learn Vulkan. I don't even have the time to learn necessarily like Osprey's user interface. I could learn one, I could learn Osprey, or I could learn VizRTX, but I'm not going to spend the time to learn both. And so this gives me the ability to, try one or the other. Maybe I like the lighting of one, but the other one renders faster. So if I'm doing VR, I'm going to probably go with the faster render, even if the lighting's better in the other one. But if I'm doing a desktop interface, I don't quite need the speed, so I'll maybe go for the better look, right? Vulkan just requires you to do a lot more work. And as I said, the using of the VTK, 4 lines of code, 4 lines of Python. For my cave renderer, I just had to figure out how to put the camera in the right position, render to a texture, and then put the texture on the screen. So a lot simpler programming than really learning Vulkan at a deep level. But we rely on Vulkan, right? So most of these things are you're going to use Vulkan, and so we get the benefits of Vulkan down at the lower levels.
So does the simplification for the development come because you're not having to drive the low-level Vulkan or DX or Metal commands, but you're just building a model in memory? Is that
right?
The right work?
Yeah, I build a model in memory. There's a few API commands to send basically arrays of data. So I send an array of locations, right, as 3 vectors of 32-bit floats. Then I send, if I'm doing a mesh, I send an array of indices into that. Or if I'm just doing spheres, I send just all the points of the spheres with the radius, and then I send a material. I line those up with a material. So I open up a world. Bring the scene graph, the node graph. I create an Anari world. You can actually create these in different orders and link them together. So I can create a world, and I can create, say, a surface, which is a mesh, has a geometry and a material that I link together, create an instance of that, connect the instance to the world, and then those instances, I can actually have an array of instances, and then each of those can have a different 4x4 transformation matrix, so I can scale them, rotate them, what have you. And so every time you create a thing and you kind of tell Anari, I've created this, now connect it to the world. And then I connect the world to the frame, right? And then the debug layer tells me, oh, you forgot to do this, right? You forgot to connect the world to the frame. That's why you're seeing black. But yeah, it's very, limited number of commands you need to learn, and you're up and running, right? All right, looks like maybe no more questions. All right, great, thank you.